if you could be my math teacher.
Sure.
Thank you.
Do I have a specific form to fill out, or?
It's on, MIT has their own platform, so I don't know what exactly it entails, but I'll send it to you.
Yeah. Sure.
And I'm also applying for Stanford. Is there a way that you could write like one recommendation letter and send it to
both.
Yeah. Oh, okay, cool. And then Stanford's on the Common App. So I will send you both the papers. Thank you, Ms. Brianna.
Sure. So, I never got to talk to Allison, but I think whatever you grade, or whatever letter grade you get here will be the same letter grade at their other college. The numerical grades may change, but the letter grade will stay the same.
Okay.
So that does mean the numerical grade will probably go down, just to keep the letter grade the same.
I gotta quickly make an A in this class.
Wait, what?
So our numerical grade will change, but we'll have the same letter grade as the college for the early college.
I think, I don't know for a fact.
We need to quickly make our grades go up.
We're the first person who's more than 50% sure, so I'm gonna take your word for it. Did you finish the homework? Yes.
I thought we finished it in class though.
No. You did do 76 in class though, right?
Yeah,
Yes.
that was the homework though.
No, it wasn't. We had to do 7.
Oh, yeah. But like the graded homework was the 76.
Yeah. The graded homework is 4.6. No, just number 76, and we did it in class, so it's okay.
Yeah.
But what is he taking up today?
He's not.
Oh. I thought he said he was taking up your homework.
No, he was just taking up number 76. But then we asked him at the end of the class, we were like, didn't we just do that? And he said, never mind, you have no homework. And I was like,
Oh, I was kind of sad about that because I could have gotten it right and I could have turned it in.
I was like, does he realize he's doing it? Because if
Oh,
not,
I thought he said he was grading your homework, like in general, for 4.6.
I don't think so.
But I was confused on 4.7. Have you started 4.7 in class? Yeah. A little bit. No.
Because isn't today supposed to be a review day if the test is due?
Because I did those and I got that. It wasn't a lot of homework. It was a lot. No, it wasn't. It was just like, this is all.
So we didn't have to do the 4.7 homework because we haven't finished it.
So with the first fundamental theorem of calculus, that's finding the area under a curve, right?
Wait, what?
I have questions. And so the second one is finding the antiderivative function to find the area under a curve. Is that right?
I just finished the 4.6 homework last night. Okay. Haven't even looked at 4.7. I'm going to read more today, so I'll figure it out tonight.
Because it says, all the way here, it says, use the second fundamental theorem of calculus to write down 3 antiderivatives of each function f in exercises 31 through 34. So does that mean that you just use that one to find the derivative?
This is the last test in this class. Yes. No. That feels so good. Because we've had tests like every week. And it feels good for that to kind of stop.
I've got 2 tests tomorrow and 1 today.
Same here. Well, not today. I have
Papers
two.
tomorrow.
Yeah.
No, then it's exams.
Christmas. I'm ready for Christmas. The only thing that's getting me through this month is the fact that we've already decorated, and every time I look at the decorations, I'm thinking this means school is almost over for this semester. Nice break. What's gonna happen is I'm going to sleep the first week, and then after the first week, I'm gonna be ready for school to start again.
Oh, same.
So that's what happens. You'd think I would enjoy the whole break, but I miss school. I like school.
Me too. Yeah, so like the first week of break, it's proportional to how much break I have. So for the first like week of winter break, I just sleep and I watch TV and that's all I do. But then for the rest of the time, I'm bored. So I get like everything done. Like my clothes get organized, my old notebooks get organized, I get organized for the new semester. It's great. And then I do the same thing for summer, only it's like the first 2 months.
No, wait.
But then last
Like,
I think it also that we're done for this half of the year. It's
like
done
we're
with the
actually
semester.
done.
Yeah, it's not like we have exams hanging over our heads because at that point I would never be ready for school to start again. But since we have a break, 1 week of an absolute break, no homework, nothing, is what I need to get started this thing where I'm treating my day like a work day. So from 8 to 5, TV, when I go home, I'm not allowed in my room because I know if I see my bed, I'm going to go to sleep.
Same.
So I'm pretending like I actually have a job at this point, and it's helping me get a lot of stuff done, especially college.
Great. I'm gonna start doing that because yesterday I went home. I didn't get home until like 5:15, and I got home and I just sat in my bed for like an hour. Like, and then I wasn't productive for like the rest of the night. Like I got stuff done, but it took way longer than it should.
Did you get 4.7?
Yeah, but I don't really know what I'm doing.
I'm gonna
So, if the area accumulation function finds the area under the curve with that little like spot, then I have no idea.
I'm just gonna progress on the bio test. I'm just gonna work
Okay, right here. The area accumulation function A is an antiderivative of the function f. Nice. So then if you have your ax equals the definite integral from a to x of f of t dt, then just wouldn't you just do the integral and then that's the antiderivative of a? Maybe that's it. Making this way harder than it actually is. Okay, I'm gonna make a list. You plug in 2 and then you plug in. And
What do you do for part C?
I don't know, I didn't do part C, I just did part B.
It's clear.
I have done up 3, 4.6.
No way we should go to
Correct.
I mean, I can help you with the homework. I can give you answers to the homework.
Yeah, that's.
I can use reasons too.
Or 4.7, or both.
Yeah.
So for 31, for 4.7, how would you do that?
31 is just for the antiderivative, so you just change the a value. So like here, this is your formula. So a of x is the antiderivative of whatever this is. So to find any antiderivative, you just change this a value and you have the antiderivative.
Did you do the 75, 76? I know we did it in class and you said we did it in the back. So now I'm like freaking out.
That's okay, I left the laptop at school yesterday.
Is this
Really? Yeah, so now it's gonna be like mistaken for equipment.
Oh, I forgot you
And
have a.
it's one and
Yep.
but
But it has my name and phone number on the bottom of it.
Are they gonna look at the barcode? Well, they'll probably know there's not a barcode. But I didn't even think of the fact that
I hope it's still there.
they'll put a sticker on it for you, like when you park the school and how owns it.
This is mine.
That was funny. I was just like, okay, why don't you just go get it? But then I realized,
Yeah.
so that means that.
and it looks exactly like the school.
It is the school name.
It is. Do you like your book?
I like it, but like, can't download anything to it. So this was just to get me through high school, which is fine. Like, I don't need a fancy laptop for high school. But for college, we're gonna get a better one.
This is the area.
That makes sense. I had one of those big bulky ones from like 2003.
Oh, don't worry, I have one of those just for games on it.
Really?
Because it's Alex's old laptop. And like, we play like games, and I wanted a gaming laptop. And he's like, well, get even new one. And she's like, can I have your old one? It's so slow.
It is.
It's so slow.
Yeah. See, mine wasn't slow because my dad replaced part of it. That was the reason for that. It was just so big, and part of it, like the side, was falling off, like the DVD thing.
Mhm.
And it still worked and everything, but it was really difficult to get stuff done.
Yeah.
And it's just one of those computers where every time you update it, it stopped working. So the computer did like a reverse update by itself. It was messy. Every time it needed to do something important, it decided it wanted to update. And my dad was like, well, we were going to wait till college, but might as well get you one. So they got me the Lenovo,
Yeah.
because he said that one's going to last a very, very, very long.
It's like it.
And it's one of those business grade.
Earlier today, solve something wrong. It's not a big problem.
It's very nice. I just wish it was
It's a
cool. My one requirement. I do like the fact that I can draw. I get nothing done. Grace was a picture of me with a collar. I need to get a necklace that says collar.
X squared plus Y squared.
All by yourself? How did it feel?
It felt different and strange.
So did
And,
you have to get
I mean, I do now.
the
They are.
Lenovo?
No, because of the whole insurance thing. Yeah, since it like boosted up the insurance because of the accident.
They disproved it. Understand.
Because I have jobs that if I paid the overage of the insurance, like he'll pay the actual insurance, but I paid the
Yeah, well, I'm
overage.
just trying to find myself. I can give you the good. There's class.
School should not grow up too much.
My parents would never make a deal with me like that.
They can,
They
they
signed
should go in.
a license to make it go.
Don't worry, that's what he did at first.
Really?
Yeah. He's just like, okay. Well, like, he told me right when I first started driving, he's just like, okay,
Change the current ends.
and then it's this accident. And then he's just like, well, you're a pretty good kid. If you pay the overage on the insurance.
Well, you're a pretty good kid.
Are you ready for this test? Which one? We have a campus tomorrow.
Feel my pain.
Have you saw her from beaches?
Huh?
Or did she marry that?
C-O-N. Oh, I thought it was H.
I'm meeting with Miss Johnson.
Miss Johnson got things done.
She did. And I feel like she could get stuff done, even though she's not the liaison. Like, she can go talk to
See, this one's just like, to take Coke too, and she's like, no.
That's something else.
Because there's only one person.
Good as hell.
Mister, when does it take it?
She's going back to school apparently.
Oh.
So, from what I hear, she's leaving next
To get
year.
her master's or?
Cool.
She's getting a
Yeah, but I don't know
graduate
if that's
degree or
because they
she's getting an
canceled or if that's
education
because-
degree.
Oh.
Because I know right now she has like a.
Yeah, I don't think it's because they canceled.
So I
because
think
here
she's
you've got
getting
the
her
director.
education.
This is
And
part of
then
it.
she'll be back the year after next.
So that's just the part.
I think so. I think
Yes,
I
we
typed
signed
it
up
out
to
at,
work the reception for the wedding.
Ellen by DT because that
Who's
is
what?
constant with respect to DX.
When is it?
And so I did one of that, and if I log in the holes, I don't know,
I'm
something.
working at it. I don't get to see the wedding. Oh, what
It's
a
very
Disney ceremony.
Because you're at the reception. You're not at the ceremony.
But Sally is like one of her favorite students. So she offered Sally, and Sally said, okay, well, I need a ride. Can my sister come too? She said, yeah, you can bring whoever you want. You just signed me up to work at a wedding where I'm
It's on
not.
top of it. It started here, and we'll see what kind of questions we have after that.
Crying for different reasons.
So, what have we covered? Section 4.4, this is what the test is on. This, section 4.4, this indefinite intervals. This will be indirectly tested. Via non-military calculus.
Oh.
I don't know what that means. Covered indefinite intervals.
It's not gonna be.
I'm not going to just give you 10 indefinite intervals to do that. You'll have to know how to do indefinite intervals in order to use fundamental theorem calculus. So rather than giving you separate problems that say just find an indefinite interval, if you can't find an indefinite interval, then you'll have trouble with that. Okay, section 1.5 was fundamental theorem calculus. And you'll be tested directly on lots of ways. The very first problem on the test
Thanks. God bless you.
is state and prove what theorem calculus. And what the first problem is on the test. Be prepared to do that quickly and efficiently. Okay, then we'll have a lot of other problems applying it. You know, many problems applying this in various ways. Most of which comes in the next, you know, some of it's just simply, here's an interval, definite interval. Use the fundamental theorem to evaluate it. But then there's other problems that come in the next sections that still use fundamental theorem to evaluate it and work on different types of problems. 4.6 was covered signed versus absolute area. Then also it covered the mean value theorem for intervals. That should all ring a bell. Signed area versus absolute area. Signed area is taking into account that you could be above or below the axis, and the negativeness of that area has meaning other than simply its negative. And the walking idea was the idea of losing ground. Mean value theorem for integrals. What did that say?
See that?
Yeah, there's at least one C value where the average height of a function is achieved. And that average height across the whole interval gives you the area under the whole curve in one rectangle. And then the last section covered was probably the easiest section, because it was simply the accumulation functions. And the second fundamental theorem of calculus, which was how to do derivative of these accumulations. So that's what's on the test. I would say the majority of it is going to be on applying fundamental theorem of calculus, just some straight up problems. Here's a definite interval, find the value. Also, finding sine and absolute area. Involved, we need to use fundamental theorem of calculus, which is mean values of intervals. So that's what's on the test. Okay. Yes.
Are we going to have to prove the set of fundamental theorem?
Probably not. Second one's easier, but use the first. Yeah, very short. You use the first one right there to prove the second one. Okay. What else? Oh, since we won't have the time to do a rework for extra credit like we've been doing, what I'll do is I'll build in a couple of bonus problems that you can do on the test for an extra credit. That way, when you get it back, you're done with it and use it to study for the problem. Next week, Thursday. Okay, so that's what's on the exam. What questions y'all want to go over? Maybe suggest going to the first chronological something. Questions on last night's exercises, and then we can back up from there to earlier exercise. Starting with 4.7, any questions on that one? 15. Find the function f given derivative of what value f of c. Find the antiderivative of f by n. Not positive, and they differentiate by how are we going to do that? 51, f prime of x is 1 of x cubed. That says what? F of the second fundamental theorem of calculus said. Say,
Antiderivative is the control. derivative.
As a prime of, so a of x equals integral a to x of f of t dt implies a prime of x equals f of x. So this was f of, that's a prime of f of x, I guess. So I could maybe say then that backwards on this, maybe I could say that a of x is go from a to x of 1 plus 1 over x cubed plus 1. I think that's that makes sense. Okay. How do we use this information here?
Use it after we found the anti-derivative.
Right. But if we can't, at this stage, find the antiderivative of that, because if we know how to do it, we know what that antiderivative is. Not someone that we've learned. So the only way to do the antiderivative would be to well, not exactly. This is when you find an antiderivative. You remember you got this like plus c going on the end, right? And that's how we found that c value by using this. We got to figure out how to use that on this question. So if we know a point, we somehow plug that in. I think we can. Use that. Let's see if they do an example. Find out matched up here. Let's see. Well, let's see. How can we use that? F of 2 equals 0. So F of 2 equals 0. So F of 2 equals 0 means that the integral from a to 1 over t cubed plus 1. Right there, hopefully over by attacking the problem.
This is fine.
That's what I just
Yeah,
saw.
so you have to find
But
the
F prime is this.
That's what I thought.
So you have to find F.
A of
So you
X.
do the
Prime
first,
of,
right?
so we're trying to find A or F.
I don't know.
I'm sorry, what? What do they have?
They have integral to the
We're just trying to find an antiderivative.
If you find the antiderivative of
Why do they choose 2 to X? That's my question.
the prime A. Because A prime
Yeah.
is so are we trying to find F or are we trying to find
You're trying to find F, that's what it says here.
A? Find F?
Function.
Find a function
They're
F.
trying to figure out what A was, but I don't think that's going to get anywhere. Because I would still have to know how to do this antiderivative, which I don't know how to do.
Wait, which antiderivative is?
Oh, so
Pardon me?
they didn't even work through it or find it. They just wrote it down.
Yeah. So I guess they just put like this.
Is that it? Why is
I'm-
that?
I was going to try to figure out what A was, but they said, let's just use this 2 value as my starting point. I guess because if that's equal to 0,
How does that work out?
they chose that as a starting point of the accumulation function because that's when it was at 0.
No.
I'm not sure what they're trying to achieve there, to be honest with you.
Yeah, I agree.
This 4 points.
Just
So I'm going to say I'm not going to put one like that on the test. Sounds weird.
Mr. Gaddis.
I don't understand the point of the question, to be honest with you. I'm not sure what it is. Question? Right now?
So why can't we anti-differentiate that one?
Well, how would we do it?
Well, when
You're
it came
trying
to,
find-
I'll just let him talk.
This is what you're trying to figure out right there, you're saying. Antiderivative. So I need to know some function so that the derivative of a function equals 1 over x cubed plus 1.
Mm-hmm.
Just do the natural log of x cubed plus 1 times.
Maybe we can figure that out.
Mr. Gaddis,
Yes, Sam?
the part that you have above the squiggly line, that's the answer they have in the. So
Okay.
aren't we just supposed to stop there?
I think we're supposed to stop there, but Reza suggested that we could actually find the antiderivative, and I'm okay.
I was just wondering why we can't.
Say it again.
I just wanted to know why we can't.
Why we can't?
Yeah, is it just because it's one that we don't know how to? Because we're so limited right
It's
now?
one that we haven't learned. Yes, it's one that we haven't learned the techniques, whatever, to handle at this stage. You can try to guess something. Since this is a 1 over as a result, I can maybe think of natural log of x cubed plus 1. And then the derivative of that is going to be 1 over x cubed plus 1, but times derivative of the inside, which is 3x squared. So that's not quite the same function. So how can I mitigate that? Well, you think, well, maybe, what if I divided this by 3x squared? That's worse now, folks. Why you think that's going to cancel this out, the thing is, it's now a quotient rule. That's going to be even a bigger mess. So at this stage of our antiderivative knowledge, we're stuck. So I guess that's why they gave it, is to say, well, look, since you don't know how to find an antiderivative, then of it, then the answer is simply to write it as an accumulation function is the antiderivative. Much like I indicated, I don't remember yesterday when I talked about the bell curve and how it was e to the negative x squared. That we were going over that yesterday with the. Since we don't know that one, even if you had more techniques, you couldn't write an antiderivative. I can't write an antiderivative. So the only way to do a definite integral is to write it as this. So I guess that was the point there. Seems like kind of an unusual point, but I'm not going to put one like that on that. So all you have to be able to do is differentiate accumulation function, and or talk about an accumulation function when it's not. Okay, other questions? Josh, Chloe, I guess whoever. Josh, go first, I guess.
Can you do number 43 on 4.7?
We'll try. We'll be more successful when we're on this one. Here's the second fundamental theorem calculus, if needed. Calculate each of the derivatives expressed as called operator. D2 over dx2 indicates that you should find the second derivative. Number 40, you said 43?
Yes.
Okay, so we're finding the second derivative. We'll try. So what is it? It's the second derivative with respect to x of, let's see how one x squared to 1. X squared to 1
Log of x to
Okay. What do y'all think? My first suggestion would be write this as the derivative of the derivative of x squared to 1 of natural log of 2. And we need to change the order so that it fits the fundamental, the second fundamental theorem. We need to have a constant on the bottom and the variable on the top. So we need to rewrite this as derivative of the derivative of negative of the integral from 1 to x squared of the natural log of absolute value of t. This negative sign is the constant multiplier, so in terms of derivatives, it can just come outside the derivatives.
Wow. Twice?
Interesting.
Negative of the derivative of the derivative of the integral 1 to x squared natural log of t dt. Now we're ready to actually start doing derivatives. We kind of got it organized in a fashion that we can start doing derivatives. The innermost derivative is a direct application of the second fundamental theorem. Since this is an accumulation function, what do I get for the derivative of this interval? Negative dx. What is this? I'm doing this part right here. Natural log of, that's the value of x squared times 2x. is correct. Right? That's what the second theorem says. You have accumulation function, and derivative is simply a function evaluated based at this upper variable limit. Since the variable is not just plain old x, it's a function of x, I have to do a chain rule right here. Now, one thing I would comment going to the next step, absolute value of x squared, since x squared is always positive, I don't need the absolute value symbols this time, so I can remove them. So this is negative derivative of natural log of x squared. I'll put the 2x in front just because I like that. Factor 2 is a constant, so I can pull that 2 out in front of the whole thing. So negative 2 times the derivative of x times natural log of x squared. So how am I going to do this next derivative? Yeah, that's a product rule. You have x times, so you have a product rule. So this is negative 2 times, and the product rule is derivative of x is 1, so natural log of x squared, plus x times, I guess that's technically 1 times, and then x times the derivative of natural log of x squared.
1 over, oh wait, it's 2x over, yeah.
Times 2x. So you have a chain rule when you do the derivative of natural log. So we clean this up, negative 2 times the natural log of x squared. It looks like here all the x's seem to cancel each other out a bunch, so that's just 2.
Got him.
I don't know what the book has as their final answer, but I'm going to stop there, I guess.
It says 38 over 6 is the answer.
What?
No, wait, wrong section, I'm sorry.
It says negative 2 natural log of x
minus 4 distributed negative 2.
and then kept the absolute value.
They distribute.
So they had negative 2 natural log of x squared minus 4. Okay?
Anything squared is going to be positive, so I say just get rid of it.
Well, this is square and
Okay.
whatever.
Josh, to answer your question.
Yeah, we're good.
Oh, you had a question as well?
Yeah, can we do 39?
$39. Now that is unusual. We got x. I wonder what they mean by that. Let's go with this board. So we got x times that forward of t. X times natural log of t dt. Integral from, what's the limit from integration? And we're taking the derivative of that. Well, I thought it's one of two things they mean. Either this x is a typo and they meant it to be a t. I don't know what their answer in the back is. Or they meant it literally as an x. If they meant it as an x, then what? Well, in terms of this integration, x is constant.
Oh my gosh.
Integrating with respect to t. If that's what they intended, there's two ways to handle this problem. If they intended it as written, then x is constant with respect to t, so this could be rewritten as x times only you can't pull a variable out of an integral like ever, but in this case, because we're integrating with respect to t, then x is in fact constant with respect to t. If this is what they intend, then what would you do? You could have a product rule or your derivative. Okay, so if I do a product rule, I'm going to get 1 times integral 1 square root of x natural log of t dt plus x times, and then I got to do something here. So it's going to be the natural log of the square root of x times 1/2 x negative. So this is integral 1 square root of x natural log of t dt plus I guess that square root of x divides into there, so I get 1/2 square root of x natural log. That's what I did. So going with what they wrote, that's what I would do. What do they get?
They got that.
Yeah.
That's what they got. Okay. And that they must have meant what they wrote.
Yeah.
Since they have typos, I wasn't sure. They must have meant what they wrote.
Yeah. Mr. Gaddis,
Yes.
what was that thing that you said where you said like you almost never can pull out a variable out of an integral?
Well, okay, so when you have a variable inside an integral, and it's the variable that you're integrating with respect to, you can't pull it out. The rule is you can pull out a constant out of an integral, right? A constant, that's called the multiple rule. If it's a constant multiplier, you pull that out of the summations that form the integral. Okay. But if you have a variable in there that is the variable with respect of integration, you can't factor that out because it's not constant. When it's the variable, then that's changing your position and your height. So you can't factor that out as a uniform constant. But if you have a variable that is not the variable of integration, it's a different variable, then it is constant relative to that variable of integration. So in this case, x was not the variable of integration. X is not the variable of integration, which is t. So x is in fact constant relative to t. But if I had, for example, my point is, if I had this x, just back up, if this x was a t, like that, so if that x was a t, then I could not do this here. Follow that? Oh, did we answer your question on that one then?
Yes, thank you.
Anybody else questions on 4.7 before we back up to another section and see if anybody has questions? 31, I heard. Derivatives function. Yeah, up again. that's kind of like we were doing before. So I'm guessing maybe something like integral from integral 1 to
Oh, it is like that.
3 to the x of sine squared of t dt. Is that what, something like
Yeah,
that?
that's how they did it back. It's the same as that other one did. They gave us another one, we can't do.
And then you to F1, well, if you do the derivative of this function, so f prime is equal to f of x, right? That's as an antiderivative. This is the antiderivative, then the derivative is back to f. Well, that gets me back to the original the function. How can I make, it said make 3 of them. Well, the second fundamental theorem, this gets me back to what's in the book, right? How can I make 3 different ones? Now let's make that a 2. There's 1. Let's make that a 3. There's another one. Okay, I'm not sure that that's the good. That's sure. What other questions? Okay, let's back up to 4.6 now and see what questions you might have. 6 was on time versus absolute area, and then the average value and mean value theorem.
Mr. Gaddis,
Yes, right.
can you do 39 from that section?
39. Right. Each pair of functions f and g on the interval use at least 8 rectangles to approximate the area of the region between the graphs. Okay. 39. X to 2. Negative 4 to 4. At least 8 rectangles. So f of x equals x and g of x equals 2. And we want the area between on negative 4 and 4. So, oops. So f of x equals x would be something like this. And let's say that this is 4 there, and there's negative 4. And then we have g of x equals 2, so that's going to be like this. X. And apparently we want the area between, so that would be this area in here, plus this area in here. And I said to do this with at least 8 rectangles. Okay, so if I'm going to break this up into 8 rectangles, I guess I would do something like that. And then I would have here maybe. And then I might have a rectangle. So I'm doing the right end of my rectangle. I do right in, that's a 0, so then right in here is going to be so I'm choosing as my approximation, I'm choosing a right in with 8 rectangles. To do at least 8, I did 8. And I chose to do the right in. Did I have to do the right in? No, they didn't say that. They just said do 8 rectangles. So what's the area of each of these rectangles? That's the idea.
Is it going to be a signed area or an absolute area?
Oh, yeah, that's a good question. But whenever we talk about area between, that's always absolute.
Okay.
I mean, I could write out, you know, the exact area. If you wanted to do this exactly, you know, we're saying the area is approximately equal to that, or the area could be exactly equal to the integral from -4 to 4 of the absolute value of f of x minus g of x. So I mean that's the exact area by definition. Area between two functions is defined by integral of an absolute value of the difference. But they wanted us not to find it exactly. That's not hard. This simple functions, but they just wanted us to approximate it with 8 rectangles. So I'm choosing to do right sums. So this number would be -3 and so on. So I got to find the area of that rectangle and add it up with all the others. So what's, you know, that's a width of 1. So we got each rectangle has a width of 1. So there's my delta x, and then I just need the height of each of my rectangles. What's the height of this rectangle? Yeah, 2 minus -3. This is y equals x. So 2 minus -3 is 5. That must be a height of 5. And then the next rectangle is 2 minus -2. So that must be a height of 4. Next one is 2 minus -1. So that's a height of 3. This one's 2 minus 0. So that must be a height of 2. Looks like I'm going to run out of room on my thing here. The next one is here. 2 minus 1 is 1. Next rectangle is 2 minus 2. So this fifth rectangle, I guess. 1, 2, 3, 4, 5, 6. How did I get so many different rectangles?
How did you get
I don't believe this. I'm carried away on my rectangle. Anyways, so this sixth rectangle, 2 minus 2 is 0, so it has a height of 0. And then this one is, 3 minus 2 is 1. And that's going to be 4 minus 2 is 2. And then the width of all of those is 1. There's my area approximation between. So it's going to be an absolute area, so it's going to be all positives. What did that number is? 18? Would it be different if you had used a left end instead of a right end on this one?
Yeah.
Clearly it would be, because you would have now, instead of starting at a 5 height, you'd start at a 6 height. You have 6, 5, 4, 3, 2, 1, 0, you would stop here at a 1. So you would cut off this last one and you would add a 6 on this end. So now the area instead of being 18 would be 22. Approximately. Okay, what other questions y'all want to talk about? Use pair functions, definite interval. Use definite intervals and funnel theorem to find the exact area between the graphs. Or x squared and x plus 2. So given an f of x equals x squared, g of x equals x plus 2, and we'll give an interval from -2 to 2. Whatever that picture looks like. Any question?
I was just wondering which number was it?
It's number 43. So it's x squared. X plus 2 is going to be something like that. G of x. And we're supposed to go from -2, which is right there, to 2, which might be right there, I don't know. So we need to find where this intersects, because the basic answer is that the area between is a -2 to an absolute value of f of x minus g of x. That's the statement of the exact area. Now, how to actually evaluate that involves determining a definite interval, which involves antiderivatives as well, using fundamental theorem. But first, we've got to get rid of the absolute value symbol. So to do that, we need to find out where they cross, so we know which one's high and which one's low. So if we set f equal to g for the intersection points, and we have x squared equals x plus 2. Squared minus x minus 2 equals 0. So x minus 2, x plus 1 equals 0. So looks like x equals 2 and -1 are the intersection points. So I did actually get that right. So there's 2 right there. -2, and so that number is -1. So we can rewrite this as the interval from -2 to -1 of the difference, but on that difference, let's see, from -2 to 1, the area between is going to be the area we're focused on right here. So from -2 to 1, f is the bigger function than g of x, so this calculation is already positive. So x squared minus x minus 2 go. Then from -1 to 2, which was the next intersection point, we're looking at this region in here, and in that region, the g function is always bigger than the f function. So to make this difference become positive, we can just multiply by negative, which is effectively subtracting the opposite direction. That becomes -x squared plus x plus 2. And the rest is, now at this stage, we're going to apply fundamental theorem of calculus to evaluate those definite intervals. So I need to find antiderivative of x squared minus x minus 2 dx, evaluated from -2 to -1, and I have to find Similarly, an antiderivative of negative x squared plus x plus 2 can evaluate from negative 1 to 2. So this is 1/3 x cubed minus 1/2 x squared minus 2x 1 plus negative 1/3 x cubed plus 1/2 x squared plus 2x from negative 1 to 2. And those antiderivatives on these were fairly simple because these are just power rules. We know a rule for antiderivatives for power functions like this. But there's a lot of them we haven't really learned, so just test and check. But anyways, these we have a rule that gives you fairly quick and easy antiderivative. And then now let's plug and chug using the fundamental theorem. So whatever that comes out to be. Like that's going to be negative 1/3 minus 1/2 plus 2 minus negative 8/3 minus 2 plus 4. This is going to be negative 8/3 plus 2 plus 8 minus. That's going to be 1/3 plus 1/2 minus 2. So whatever that comes out. Let's see. That convert to sixths, it looks like. So negative 2/6, negative 5/6, plus 12/6, 7/6, plus 16/6 is 20. 3/6 plus 12/6 is 5/6 minus 1/4 is 7/6. Minus 66 is negative 5/6 plus 36/6 is 31/6. I'm about to get lost here. 38. I was going to get there. I was getting lost. 38%. Any other questions in 4.0?
Can I ask a clarification question about that? How do you decide with the area in between graphs? How do you decide which part of the piecewise to make negative again?
Well, there's two ways to do it, Ray, though. Method one is geometric. So I look at this graph, and I want to think of making, like I did over here, I want to think of making positive rectangles. So if I was going to draw in a rectangle here to represent a slice of area in that region, then to calculate a positive area, I would want to do the high function minus the low function, which is f minus g. And that's exactly what I have right here. This is f minus g. So in this region, f minus g gives me a positive answer. But in this region here, and geometrically, if I'm going to do high minus low to get a positive rectangle, then I've got to do g minus f. But since this was f minus g right here, so this was f minus g, and in this region, f minus g is positive, but in this region, f minus g is negative. So if I want to make a positive result, I would actually just subtract g minus f is now positive, but I can create g minus f by simply doing negative of f minus g. So that by multiplying by a negative sign, that gives me a g minus f. So if I'm just doing it geometrically, I'm just going to take the high minus low each time in each region. If I look at the picture and say, well, there's the high function, there's the low function, I can't go wrong because I want to be positive if I subtract high minus low.
Mm-hmm.
How do I do it if I don't have a graph? If all I have is the functions. How can I figure out to change from this and remove absolute values and know which one gets a plus and which one gets a minus without looking at the picture? How do I know that? Like what I would do is, if I found out that I'm intersecting at -1, so left of -1, I have to decide which one's high, which one's low. Plug in a value. How about pick a value like, say, -2? -2 over here, if you plug in to F, you get a 4, and if you plug in -2 to G, you get a 0. So F is clearly bigger than G, so F minus G is therefore positive, so I don't need to do anything to it. But if I pick a value in here between -1 and 2, like let's say 0, if you plug in a 0, F is 0 and G is 2, so G is the bigger. So that means the difference, F minus G, so 0 minus 2 is negative, so we need to make it a positive, or take off that value, then I have to put a minus sign on that function to make it become positive. I have two ways to decide when you multiply by negative, when you don't, depending on the value. Does that answer your question, Reza?
Yeah. Thank you.
Naturally, high minus low always works. If you don't have the geometry to look at, then simply look at two values in the region, and if the difference is negative, then you got to multiply by a negative sign to make the difference positive. Sammy, another question?
I ended up getting -17/3.
Okay. I don't think it should be negative, to be quite honest, because the directions were to find the area between, and area between is always defined as absolute area. So it certainly should be a positive number, first of all. Does that make sense? Mm-hmm. I'm not sure. I'd have to see your work to figure out how you got a -17/3. You follow what we did here? I would go back through this.
Yeah, I followed along, but when I added all the fractions, I ended up getting -17/3.
Okay, so you got these fractions, these evaluation fractions, and you're saying you added those up and got -17/3.
Yes.
I'm going to say that's probably not true, because I was well over positive when I got to here and I stopped working, and this isn't much taking off when you're adding on another 2. So I'm going to say that this is probably right. Anybody else get 38/6 as their answer?
I did.
Yeah,
Yes,
I got
girl,
19/6, which is the same thing.
So I'm not sure, Sammy, but potentially it could be, I'm going to guess, a likely mistake is a minus sign. Like, if you don't distribute this minus sign to all of these terms, or if you don't distribute that one to all of them, that could mess things up. Or, you could put everything in with the parentheses, like minus the parentheses, that will automatically take care of the minus sign for you.
Nice.
That would be my first guess, that there's likely a minus sign that got missed, but possibly you might have typed in one of the numbers wrong as well. So I'd have to look at your calculator and see what you did there. I would say hold it up to the video, but I'm not sure I could even see it then. Somebody who got a 38/6, can they look at Sammy's calculator and see if we can help spot? What did you get?
I got a 6.
You got a 6. What did you get? Okay, so 38/6 reduces to 19/3.
Got
I
him.
don't know if you'd understand it.
I get 19/3.
We got a 6 over here. We got a -17/3.
But I solved that.
Once again, this is math by democracy. All in favor of answer A, vote.
I believe in
That's
autocracy.
34%, which is close.
We're an oligarchy. The Olive Garden.
Oligarchy.
Oh yeah, Mr. Gaddis.
Yes, right.
We went over the proofs for both of the fundamental theorems of calculus.
Yes.
We expect to use them tomorrow.
Do I need to prove?
Basil came in about 10 minutes late again.
Yeah,
Can we pay him back over here to this first board? Basil, here's a suggestion. You might try setting that alarm clock about 10 minutes earlier. That way you won't be late.
Yeah, you're right.
Here, that's what we need to
I just want to make sure. Yeah.
So on this board here, we review what we're going to have on the test. And right here it says the first problem on the test is state and prove fundamental theorem of calculus.
Since we don't have time to do test corrections, there's going to be extra credit questions.
Mm.
Yeah. So we don't know how we do it.
Sure, I mean, we're about out of time, but I mean, we're in 9:03, but I'm glad to answer more questions. If someone needs to leave, that's fine. If you need to head out, or I can let you know. Joe, what's your question?
You see that? So
4.6, what number 6?
it's the 9/73.
69173. Okay, let's take a look at 6.9. For each function f,
Yeah, but I don't know
the interval given, find the real number c such that f of c is the average value of f on a then use a graph to verify that the transfer is reasonable. Okay. So f of x is 2x squared plus 1 or -1 to 2. So I need a little support space. So f of x equals 2x squared plus 1 on -1 to 2. Did I get that right? Okay. And we want to find the c value that gives me the average height. So first thing I'm going to do is just go ahead and get a quick sketch of this function. The 2x squared plus 1 goes to 1. It's a parabola, really steep parabola, and we're going from -1 to 2. So we're looking at values between here and here, maybe. We want to find the average height of that function in that region. Now I've got a lot of low values here, and I got some high values, so maybe my average height is about there. And if that's the case, then there would be some c value that creates that average height. So this number here is the average height, average value of the function. And there's a c value that creates that according to the mean value theorem. So how do I figure that out? Well, we learned that the average value is simply the sum of all the values divided by the number of values. But since there's infinite different values in that little interval, then the way to find the sum is to actually integrate. And then the number of values, instead of counting them individually, we'll just take the width of the interval. So 2 minus -1.
That's a little rough.
So this is my fundamental theorem of calculus. This becomes 2/3 x cubed plus x from -1 to 2 over 3. And then whatever that is, let's see, that's 8. 16/3 plus 2 minus -1 is -2/3 minus 1. 3. 18/3 makes 6, I guess. And then plus 3 more is 9, so 9 over 3. So the average height of this function is 3. this number here, 3, is equal to the average height or average value of the function. It varies from a height of whatever that is to all these different heights. That's the average value. You take into account all the different heights in that region. Where does it occur at C value? So we set f of C equal to 3. 2x plus 2c squared plus 1 equals 3. So squared equals 1. C equals plus or minus 1. Which one are we going to use there?
Positive one.
Positive.
I know, go back.
Okay, it can't use both. That's a good suggestion. The C value has to be in the open interval, not the closed interval. So I can't use the negative this time. I have to use the positive because it has to be in the open interval, -1 to 2. C has to be an element of the open interval, -1 to 2. My C value is +1, right there. There's a 1. And what does that all tell me? One more time. So this is a 1 right there. And the area under, which my graph is off now, but because my 1 that point should be up here, but whatever. Anyways, the rest of the issue besides calculating that is what does it all mean? And it says that if you take the area under the average value, so if you take a single rectangle at this average value, that area under that single rectangle whose height is 3, so you got a height of 3. How wide is this rectangle? 3. 3 by 3 has an area of, that area of that rectangle is 9, okay? Well, now, where else could we see a 9 in this problem? That 9 right there, see that 9? That represents the area under the function. So the area from here all the way to there is also equal to 9. So what we found is the average height,
That's crazy.
and a special C value that generates that average height. And since it's the average height, then it's like driving, think about driving. If I'm driving at an average speed, if I stay at that constant speed the whole time, then I get the same distance as if I'm driving all over this place at different speeds. You can get there by driving different speeds or all one speed, but it all comes out in the end. That's what this is. I can get the average height times the width, I get the area, or I can get the area under the whole curve. They match up. That's the point of that whole mean value theorem. Okay, so I guess we're about done. See you tomorrow. We'll have a plan for extra time again for the test. So, any last parting questions, anyone? Calculators are permitted, but you will have to show all your work because I want to see your thinking process as much as your final answer. All right, see you tomorrow.
I got Miss Johnson to push back the essay.
I know, I saw.
Yeah.
Thanks. Wait, until
Midnight.
You gave it. That's what
I thought Mason was supposed to
started
do
out for us.
Yes, Mason was supposed to be
both of
back.
our review dates.
That was me.
There are different ways to say
They
things.
changed the last
There's
one.
ways to
I'm not
say
kidding.
things
I
that
don't
go wrong.
think so.
Right.
I went to bed super early yesterday.
Yeah, I know. I tried texting you about like
I went to bed at like 8:30.
It doesn't have to be, it doesn't have to
Woke
be a
up and I'm like, I still
snapshot
can't.
exactly, but
It doesn't matter how early I sleep. I just can't.
I try to get it as.
It's not in my power.
Cover all-
I tried to study yesterday, but I just ended up reading Quixote.
They wrote a page and a half in small type.
Yeah.
I got it pretty bad already.
But I want to leave because the competition is in January.
Yeah.
That's just one problem. So Well, I just don't know.
Oh, you know the tape
Those
in
sites
the
were-
floor? Yeah, we did that.
Because it went to
Yeah,
X,
no guns
I-
in the file. So,
okay,
I have time.
above it, we clogged it below it, we make.
That's exactly the idea.
Yeah.
I mean,
That's
it's,
how I thought about it.
instead of, I mean, because you could make this, I mean, that's exactly the idea. When you do just a single function and you talk about area above and below, I mean, yeah, you can imagine that that's just a tilted axis. That's exactly right. Area above and below.
Is it possible
Well, I mean,
Like,
yeah, I mean, we
switch
did.
them around?